Hey everyone, in this video we're going to look at modeling the spread of a flu epidemic. So the logistic growth function f of t, and we've got it down here, describes the number of people, f of t, who become ill with influenza t weeks after its initial outbreak in a particular community. So how many people became ill when the flu epidemic began? Well, this is t equals 0, so I'm going to pull up my calculator. And I'm going to store 0 as my variable, and then I'm going to take 100,000, so 1, 2, 1, 2, 3, that's 5 zeros. I'm going to divide it by this expression, 1 plus 5,000, exponential function, so second e to the negative variable, so negative x. And I close up the exponent, I close up the denominator, and I'm going to hit enter, and I will get 20. That is spot on close to 20, so I might even write it as 20.0. How many people became ill? F of 0 is equal to 20.0 people. Great. And now part B, how many people were ill by the end of the 4th week? T is equal to 4 in this case, so I'm going to look for F of 4. So it's the same thing as before, except 4. Now I'm going to store that as my variable. Great. And then I'm going to pull up that old expression. I'll hit enter, and it'll be computed with the new variable at the end of the 4th week, and I think it makes sense to go to the nearest person. We'll have 1,080 people. So we want to know what is the limiting size of the population that becomes ill. For this exponential function here, the denominator e to the negative t is in the denominator, and e to the negative t goes to 0 as t goes to infinity. So this is going to go to 0, which means what we'll end up with is this function going to 100,000 over 1 plus 5,000 times 0. Well, that's 0. 100,000. So the most people that could be sick is 100,000. And that makes sense. We can't have 120,000 people sick in a population of 100,000. People can't get so sick that they count for 2 people. All right. That's it for this problem. I'll see you next time.